This video will continue in your textbook with the proton wave. It'll start at roughly exercise 955 and work our way through. And so some of this code I've already written in, so we'll take a look at the proton wave. One thing that we wanted to add was a sound. And so we're going to add a sound, greenfoot dot play sound proton wave. And that wave file should already be in your folder, so you shouldn't have to worry about moving that in. And I believe that's the only thing that we need to change in proton wave right now. If we didn't, the private integer current image equals 0, that should be set. But I believe that we already did that in the last video. So now we're going to actually implement this in one of our other classes. And if we take a look at all of the classes in our Greenfoot environment, the one that we want to work with is going to be rocket, because the rocket fires, and that's our first weapon, but we also want to have it access this second weapon, which is a proton wave. And so I've made some changes already. We're just going to kind of scroll through here and take a look. One of the things that we're going to do is we're going to make it so that we have keyboard access. So we're going to write a method that's going to call the proton wave and check keys. And it's not really a method, it's going to be a if statement. So this if statement right here, if greenfoot is key down Z, is going to be our letter to access and start a proton wave, then that's going to start our proton wave. Start proton wave we have not created yet. That's going to be a method that we're going to want to write. So get that if statement written into your code. Remember that it's the letter Z that you're going to press. And then let's look at the code for the proton wave. I already wrote this in. So the code that we have so far is private void start proton wave, and then we need to create a proton wave and actually have it added to the current world. So proton wave, and our current proton wave is just going to be called wave, and we're going to create a new proton wave, and we're going to add it at the current location of this object. We're in the rocket class, so the proton wave will be added at the current location of the rocket when we use this get X, get Y. So this last phrase or line of code that you should add is get world, add object, and the object we're going to add is the current wave that we just created. Compile that code, and we take a look at what it does. It will create a proton wave when I press the letter Z. Although we also see that we just got ran over by an asteroid. So let's try that again. I'll try to put my ship away from the asteroids. So there's my proton wave, but if you look, it's not destroying any asteroids yet. And I just got killed again. So let's see if we can figure out where to put the proton wave in order to kill the asteroids. And it's not really more a question of where to put the proton wave as to which class or what method we need to look in. Our new method that we're going to add will check for a collision, but we actually are going to need to move to a different class to do that. This check collision is going to check to see if a spaceship intersects with an asteroid, and so we're going to want to move to a different class. We have to check a collision with a proton wave. Before we do that, I don't know if you noticed that the proton wave was actually being accessed fairly quickly, and we want to put a delay on that. I'm going to go ahead and do that code now, and it mimics some of the code that we did with firing, I believe, or that the program automatically does with firing. But here's going to be the deal. If the proton delay count is greater than or equal to the proton reload time, Then we're going to go ahead and create a proton wave in the world. And then we're going to add to the proton delay count, or reset the proton delay count. What happens then is we're going to want to add to the proton delay count whenever we call a proton delay or whenever we act. And if we take a look at our act method, scrolling up or down, we got to find it. It already does a reload delay count for our firing, and we're just going to add a proton delay count. You'll need to study that code a little bit more and ask questions about it if you don't understand it. There is some more descriptions in your textbook on that. Now we are going to move to the proton wave and check for a collision. And so we've got an act method, a grow method, and we have an initialize images method. We are going to now have a check collision method. So in the class proton wave, this is exercise 962 in your textbook, page 173. It's going to add a method stub for a check collision. It has no parameters, does not return a value, and so we're going to do private void check collision, and it's going to be similar to our other check collision, except this one's going to be used in the proton wave. Not going to write anything in there, but what we should do is that should be called every time we run through a cycle of this program. So we're going to add that to our act method. So check collision is going to get added to our act method. We are going to try something different in this act method in this respect, and that is, remember when the objects interact or just barely touch, or their rectangles touch, that their boundary touches, then they consider that a collision. We are now going to do a collision within a certain range, and so we're going to try this new method, objects in range. Please notice it takes in a radius and a class, and it returns a list. So the other reason for that is if I do my proton wave as it extends out, I want to be able to catch any object, and there might be multiple asteroids within there rather than just one object. And so that's the method that we're going to be implementing. Your textbook talks through it a little bit more here. I'm just going to go ahead and write the code with you. We are going to use that asteroid list, and let's see what that looks like then. So go back to your proton wave, and we're going to go to the check collision method, and we are going to get a range of numbers. That's going to be an integer value, and it's going to be within a certain distance from the image. So we're going to get the image, and then we're going to get the width of the image, and we're going to divide it by 2. You could play around with that if you want to increase or decrease that range, but within that range we are going to get a list of all of the asteroids. And asteroid is what we're looking for. The actual name of our list we're going to call asteroids, and we're going to use that method, get objects in range, and it has to be within the range, and we have to tell it what type of object that we're looking for. So that's an asteroid. I'm going to hit compile here to see if I typed everything correctly, and it says it cannot find the list, and that's an indicator that we did not use the right import statement. And if I go all the way back to the top, we have import.greenfoot, but remember, whenever we need to use a list, we need to import the list, and it's going to be I'm going to look at my notes, java.util.list. And the list is capitalized and util is not. Now when I hit compile, I find that I didn't error trap my other code for proton delay count. It says this cannot be found, and that's because I didn't declare it. So we need to add that up here as well. And so that should then successfully compile. If I can spell int. And likewise, I also have to add a proton reload time. And that's just giving us a starting value for how long to reload. Our textbook set this at 500 to start with. And so we will also use that same value. Clean up my code. Cross my fingers. That compiles. And did our proton wave then compile? Okay, I jumped back to the proton wave class here, and we're going to finish up the check collision. And that little exercises we just did is an example of why it would be wise to hit compile more frequently to make sure things are spelled correctly and declared correctly. So last but not least, we now have our list of asteroids, and we need to just go through and check to see if each asteroid has been hit. And we're going to apply a certain amount of damage. If we take a look, damage is assigned 30, so we're going to award a damage of 30 if the asteroid is hit. And we're going to use a for each. It's been a while since we used one of those, but a for each is a shortcut. And so what's going to happen is for each asteroid on our list, so that's what A is going to represent. For A is going to be a particular asteroid on our list. And the name of the array for a for each loop goes here. So a for each loop is processing a list. It only works on a list. It's going to take every asteroid in asteroids, and that's A, and it's going to check and assign a hit, and then assign it damage. Damage is a constant, so it needs to be declared in all capitals. If we test out our code right now, you have to survive for a little bit of time in order to actually test the proton wave. Since I'm not that great at the game, I usually fail. So what I do, I'm going to cheat just a little bit. I'm going to go back to the proton wave, and I'm going to decrease the time that I need. And I don't know if that's in proton wave or if that's back in rocket. So let me take a look quick. Might be in asteroids. Right here, the reload time. I'm going to make it 10, which is slightly more than firing the rockets, just so that you can see how this works, and also so I don't die before it works. And so we're going to run this again. If I press the letter Z, I throw a proton wave, and the asteroids nearby disappear. That is going to be it for now. And we still need to do scoring, but we might kind of leave that for you to work on. That's exercise or section 910 in your textbook.